motion. We're just making out the schedule for next spring, in the spring of 2017. And I just want to know if you're intending to take the lab. So are you taking the lab in spring 2017? If yes, do A. If B, do no. It just helps us to know sort of how many sections to offer. Because we have a funny group this semester. So if A, yes. If yes, do A. B, do no. Yeah. This is the lab with the second semester of the lab. Physics 204. If you're biology, you have to have it for graduate. But some of you don't require it for various reasons. If you're some free, something or another. But if you're biology or free med or whatever, you have to have it. Yeah. All right, just a few more seconds. Just guess if you don't know. No. I want to stop. Okay, let's see. So we're going to wrap up projectile motion, and then we'll probably start on Chapter 4 today. Chapter 4's quiz will be due not on Friday, but on Wednesday. Y'all know what next week is? Y'all knew that, huh? I thought I was going to surprise you with it. The next week is fall break, so we'll just have that quiz due at the end of that week, which is Wednesday. Huh? No way, you know about exams. And many of you have lab midterm next week too, so make sure you keep that in mind. Lab midterm. All right. So, what do you do when the time's not given? Well, when we don't have the time, we have to find the time. We've had a bunch of problems where we're determining the time. What is it that we almost always analyze to get the time? The y motion, almost always. So we can analyze the y. And that's all that we've done so far. Analyze the y motion to find the time in a couple different ways. One, we can say, v top is equal to 0, and then you can say vy equals v naught plus at, that's ay, and v naught y. And we've done that a couple different times on various problems. Another way is, as we did also, and depending on your problem that you're doing, you might be able to do it either way, is that you can say over here that y is equal to 0, and then you solve this, y is equal to v naught y t plus 1/2 ayt squared, and you solve that for t. Remember, we got those two solutions, that y is equal to 0 here, and then y is also equal to 0 over here. We did that way as well. Another way, which we've also done, we did in an extra little problem, which was also like one that you had in your quiz, is where, what if your y position, your final y position is not 0, but it's something else? And in that case, like say that you know what this is. I think in our problem it was like 2 or whatever meters. And then you would say y equals v naught y times t plus 1/2 ayt squared. So you can analyze your y motion if you know the velocity or the y position at a particular point and find the time at that particular point. By the way, with this final one, you have to use the quadratic for this. You won't have to do that on the exam, but you had to do it on the assignment that you had to do last week, and you have to do it in the lab that you're doing this week on projectile motion. Okay, another way that will come up occasionally is to analyze the x motion. And this is only if you have information about Vx and x. Because you remember that when I have an object, it travels a certain distance, x, between here and here, and that value for x is equal to Vx times t. Or sometimes you might have a different x, like let's say I want to know the time when it's at this distance, then I can just put in the value to find the time at this position, doing x equals Vxt. Those of you that are in the lab, this is like when you put the ring, I know not all of you are in lab, but when you get to the last section, when you put the ring and you're trying to shoot it through the ring, that's how you find the time. You know the x displacement and you know the velocity, so you can find the time. If you don't know what I'm talking about, I know about half of you don't, that's okay, but you'll see it when you get to classes. Okay, so a couple different ways, either analyzing the y motion, which is more common, or we analyze the x motion. See, I think that we have a problem here where we're going to look at the x motion. Or maybe not. Let's try this one there. All right, a stone is thrown horizontally from the top of a 125-meter high cliff with a velocity of 10 meters per second. How far does the stone land from the base of the cliff? Your first thing will be able to find the time. I want to know how far it lands, so I want to know the time when the stone lands at the base of the cliff, down at the bottom. I always find that it helps me draw a picture. I'll draw a picture for you here. It's my cliff. My object, it goes off horizontally. That means that it's pointing straight out, right? So it starts out like this. And I'm looking for x. Did we get Evan, Tesha, Andrew, Barbier, or Bailey come in? I want to show you something. We're going to talk about this later, but I want to show you about this little thing. This has to do with this problem. So let me just show you. This is just a little device. It will take a ball and it will kick it out to one side, and then it also drops the ball simultaneously at the same time. So I have these two balls, two metal balls. One will get kicked out to the side, and at the same time, one will drop vertically. All right, now, what determines the time that it's in the air? The y motion. So if I have these that start at the same y position, one of them kicked out, this one will kick out, and it'll go towards there, and this one will just drop straight down. Which one is going to hit the floor first? They should be at the same time because they're both falling the same height. I'll do it up here. I'll go back in the back in just a second, but you can just listen for the clicks. Are you being quiet? You hear how they hit at the same time? You hear how they hit at the same time? I'll go back here so y'all can see. So the point of that is that how long it takes for it to fall is going to be the time that it's in the air. Already. All right, let's try to wrap this up in about 20 seconds, okay? All right, I'm going to stop at 5:05. Just guess if you're not sure. Just 5 more seconds. Okay, awesome. All right, B, I think, is the right answer. First thing we want to do is find the time. Find the time. We're going to say y equals v naught y times t plus 1/2 ay t squared. V naught y is 0, so this whole thing just goes away. I can forget it. Y is equal to, gosh, I think it's 125. Well, I'm sorry, what? It is negative. Thank you. I was going to point that out. A is negative 10, and then t is squared. And so I solve that. The negatives go away because I have 2 of them. 125 divided by 5 equals 25, and that's equal to t squared. So I square both sides, and all right, take the square root of both sides, and I get t equals 5 seconds. That's not the answer, though I know that a lot of you would put C, right, because you get 5, and then you think, oh, that must be the answer. But no, the answer is x is equal to vx times t. Now we need to figure out what is vx. And what's key here is that it's thrown horizontally. That means that there is no y component to the velocity, only the x component. So Vx is 10 meters per second times 5 seconds, and so that is 50 meters. All right, so B is the right answer there. Why wouldn't what be 0? It's thrown horizontally, so it's just like with this thing, right? It kicks the ball out with a horizontal velocity. It doesn't have a y component to the velocity. So on this, Vx equals to 10, but Vy is equal to 0. My initial velocity, V naught, is equal to 10 meters per second, but my angle theta is equal to 0 degrees. And so remember, Vx is equal to 10 times the cosine of theta, but the cosine of 0 is equal to 1. So this is just equal to 10 meters per second. Okay, good question. So why do we use 0 here? Because this is the y component of the velocity. What's key in this problem is that it's thrown horizontally. And so I have this initial speed of 10 meters per second, but the x component is 10, and the y component is 0. The sine of 0 degrees is 0, so the y component goes away. And that's why here I use Vy is equal to 0. All right? Right, you're just, I mean, it's like you're standing up, just like in the lab, I don't think you've done the lab yet, but in the lab you do this exact same thing. You shoot a little metal ball horizontally. Right? Okay? Y'all good with me on this? We're going to do a couple more, but then we're going to move on from projectile motion and move on into chapter 4. We have a bit more to do, even though we're at the end of the chapter here. I think we're at the end. But I wanted to work a few more problems. Let's finish up these questions too. By the way, I just want to remind you that, on the test, there were some questions there that came verbatim from these, and so it is good for you to study through these concept tests. I often will go through them. If I don't pull them verbatim, I'll pull them similarly. And then also with the OpenStax assignments that you're doing online, I pulled some questions from there. So if some of you might have noticed there were, 3 to 5 questions that were from the OpenStax assignments. Those 6 to 7 questions that I give you. All right. So just as you're going through those quizzes, keep that in mind, that you should go back and look at those again before the next test. Okay, you with me on this? Okay, good. I want those OpenStax quizzes to be a double, not a double whammy, but like a double bonus for you. That you get them right on the quiz. You can use whatever resources you need, and then because you get them right on the quiz, you also get them right on the test. That's my intention. It benefits you twice. Okay. Where do we leave off here? Does somebody know? 3.6. Yeah, we did this one. Yeah. This one is where we left off? Okay. All right, I'm going to stop at 35. 35. Guess if you don't know, ask your neighbor. Okay, awesome. C is right. It's just like we did before, right, with the little box, the little metal balls, because the time that they're in the air is dependent upon the y motion. And since they both started at the same y position, they're going to have the same amount of time in the air. Even though really one's going further, because it's going out in the x direction as well, they still fall in the same amount of time. Last night, the police, they came to my house, and they said, Mr. Young, can we have a quick word? And I said, sure. Velocity. You get it now. Yeah. All right, in the previous problem, which ball had the greater velocity at ground level? So they both had the same time. They both took the same time, but which has the greater velocity? Drop, fired, do they have the same velocity, or does it depend on how hard the ball is thrown? All right, let's do 45, just about 10 more seconds. Okay, so I have one ball and it drops in this direction. If I were to draw the V versus T graph, Vy versus T, it would look like this, right? The velocity will increase in the y direction. And then I have another ball that goes out like this. All right, if I were to draw Vx versus T, it's going to look like this. Because the acceleration in the x direction is 0, the velocity in the x direction remains the same. However, if I draw Vy versus T, it looks exactly the same as it did over here, because it's accelerating in the y direction. And so now I want to know which ball has the greater velocity? Not the greater x velocity, not the greater y velocity, but the greater velocity overall. Let's try it again. The job sort of did mediocre on that previous time. Well, let's try it again. Ask your neighbor. Feel free to ask your neighbor what they put. About 30 of you got the wrong answer. Let's try to do better than that. All right, about 10 more seconds. Feel free to ask your neighbor. Please do ask your neighbor, in fact. Stop at 40. Okay, that's a little better. It is B. The fired ball has a greater velocity because you not only have the y velocity at the bottom, but you also have the x velocity. And so in order to find the total velocity, you have to do the vector addition, adding up the vx and the vy. Projectile is launched from the ground at an angle of 30 degrees. At what point in the trajectory does the projectile have the least speed? Think about what happens to the speed throughout. Okay, awesome. Just about 8 more seconds. I'll stop at 40. Awesome. B is right at the highest point. Now, is it speed 0 at the highest point? No, it's not, because it still has that x velocity. All right, but the velocity in the y direction is 0 at the highest point. So, did I mark it correct? Yeah, so B is the right answer. What did the dog say after a long day of work? Rough. Which of these 3 punts has the longest hang time? Let 1 be A, 2 be B, 3 be C, and then D is here. Which has the longest hang time? Let's stop in about 10 seconds. 45, 45. Okay, good. D is the right answer. They all have the same hang time, but then you say, that doesn't make a lick of sense, because this one went so much further. How can it have been in the air the same amount of time? Right? Remember, the hang time, or the time that it's in the air, is completely governed by how high it goes. Right? If it goes up high, it doesn't matter how far it goes in the x direction, but if it goes up high, that means that it's in the air for a really long time. If it goes down low, that means it's in the air for not very much time. Don't be tricked into thinking that the x displacement has anything to do with the hang time. The x displacement has to do with other things like the angle and the initial velocity, but not with the hang time. The hang time is only dependent upon how high it goes. If it goes higher, it's in the air for a longer amount of time. So D is the right answer here. All right, a battleship simultaneously fires 2 shells at 2 enemy submarines. The shells are launched with the same initial velocity. Which submarine gets hit first? A, B, or is it C? They both get hit at the same time. They do have the same initial velocity, which submarine gets it first. This one, or both at the same time. All right, stopping at 45, just a few more seconds. Okay, B is right. Remember, don't be tricked into thinking that just because it's further away, that it took more time. Because the only thing that gives the hang time is what? The y displacement. Since this one has a lower maximum height, it's in the air for less time. This one has a bigger height, it's in the air for more time. For a cannon on Earth, the cannonball would follow path number 2. Instead, if it were on the moon, where the acceleration due to gravity on the moon is 1.6 meters per second squared, which path would the cannonball take? So on the Earth, it follows this one. On the moon, which will it follow? A, B, C, or D? That's your numbers, V letters, please. All right, let's stop at 55, 5 more seconds. D is right. Good. So what happens here, the acceleration due to gravity is less on the moon, and so that means it's going to drop at a slower rate. That means it's going to be in the air for longer. That's why when Neil Armstrong, you see him jumping up on the moon, it looks like he takes it like he's floating almost, because the acceleration is less, so his velocity changes at a slower rate. And so it's going to drop at a slower rate, giving it more time to get out a further distance away. So D is the right answer here. Spring-loaded gun can launch projectiles at different angles. What angle should it be launched to get the greatest distance to travel? We'll stop at 30. Stop at 30. Okay, good. C is right. 45 degrees gives us a maximum range. The reason it gives us maximum range because it maximizes the time it's in the air. Because notice if this is 45 degrees, it gives me a certain Vx and Vy. It gives me a Vy in this direction and a Vx in this direction. If I make it bigger than 45 degrees, my Vx is smaller, but my Vy is bigger. Now in this case, this will give me more hang time. It'll go up higher, but it has less x velocity, so it doesn't go as far. On the other hand, if I have a really shallow angle, I get a big Vx, but I get a little bitty Vy. So in this case, not much hang time because Vy is small, even though I have a big Vx, but it's not in the air long enough to go very far. So 45 degrees, even though it doesn't give a maximum Vx or a maximum Vy, it maximizes those two values together to give you a maximum range. Y'all follow me on that? Well, how that works? Good. I didn't know why the baseball was getting bigger, but then it hit me. All right, you're trying to hit a friend with a water balloon. He is sitting in the window of his dorm room directly across the street. You aim straight at him and shoot. He falls out of the window, does the water balloon. So you aim straight across. So straight line across. But then just as you shoot, he falls. So what happens? Does it hit? Does it maybe hit? Does it miss? Is it impossible? Or you're not really sure? It does have enough speed. Assume that the shot does have enough speed to reach the dorm across the street. You're aiming it straight across, Adam. You're aiming it straight across. That's what it says. All right, just a few more seconds. I'll stop at 112, 112. Just guess if you're not sure. Okay, A is right. What's going to happen here is that you shoot the ball and it falls like that. It falls at a rate of 10 meters per second per second. Similarly, this guy unfortunately falls at the same rate. So when they meet there, they're going to meet at exactly the same point. Okay? Because you're both falling at that same acceleration. If it had enough speed to reach the building, yeah. No, like if you were trying to hit your friend and you didn't know he was going to fall out of the window, then this would be a bad way, right? How would you, if you wanted to hit him, what would you do? You would aim up so that it would arc over and then reach him. Have y'all ever done this? No, you can't even open your windows, can you? Can you open your windows in your dorm? No. Okay. Y'all like living in the dorm? I know not all of you do. Do you like it? It's okay. Okay, you're on the street and you're trying to hit a friend with a water balloon. So same situation basically, except you're on the street. And so you're aiming straight up at him. But then just as you shoot, he falls. What happens? I don't know if he survives or not. It does have enough velocity to reach him, yeah. All right, we'll stop at 50 seconds. 50. Oh, 50. Okay, A is going to be the right answer here too. Now what's going to happen is you'll shoot this and it's going to follow a path that looks like this. And in the time that he follows that path, because you have the same acceleration, this guy is going to fall down and you'll both hit at the same time. So this is useful stuff if you're trying to hit your friend with a water balloon as he's falling out of a window of a tall building. Okay. Let's do a few more questions for projectile motion. We'll look back at the old exam in the back, the fall 2015 exam. Let's do a few more questions before we move on to chapter 4. For a little extra practice. Listen, if you feel like you need more practice, like 2/3 of the class needs more practice, so that's okay. Yeah.
In my homework, it gave me a problem and it gave me the angle and it gave me the height and it asked me to find my angle velocity. I think I had that. And it was, I asked like 20 people. Yeah, for the personalized.
Was it on the OpenStax?
Yes.
Let's see, so it gave you the angle.
It said the angle was 30 degrees, the maximum height was 10 meters. What was the initial velocity?
Oh yeah, we could do that. You want me to work that right now? Okay. You can just, I'll just do it right here. There should be extra space back in your chapter, but I'll do it right here. So we had a maximum height was what? What? 10 meters. This was from your OpenStax quiz. And the angle,
And this was a personal expression, so maybe not everybody.
okay, maybe not everybody had this. If you haven't figured this out, on your quizzes, your assignments, you have 5 or 6 questions that I've assigned, and then they draw them randomly from the whole bank. And it can actually go back to previous chapters. I don't like it. I know y'all don't like it either, but I've tried to get them to change it. And okay, so where was it? Theta was what? 30 degrees. And I want to know V naught. All right, so it follows a path that looks something like this. Let's see, what do I know? I know that this angle is 30 degrees. I don't know V naught, but I want to know it. I also know that right here, this is 10 meters. I also know that velocity in the y direction up here is equal to 0. I know that Vy is equal to V naught sine theta. Now let's write down our equations. We're just going to be using the y equations here. So I'd say y equals V naught y times t plus 1/2 at squared, ay. And then I also know that Vy equals V naught y plus ay times t. Now I want to write down and just sort of see what I know and what I don't know, and then we can develop an approach, a mathematical approach for this. So I'm going to underline in red what we don't know. I don't know V naught y. I don't know t. I know Vy, I don't know V naught y, and I don't know t. So is it falling out to you now a little bit? Some of you it is. You have 2 equations with 2 unknowns. You're going to have to substitute one equation into the other equation to solve for one of the unknowns. We have done this before, but I don't have those kinds of questions on your test just because they're cumbersome. The algebra is cumbersome, but you can certainly see it on the online quizzes. So the way we would do this, well, first let's just simplify it a little bit. I'm going to say Vy is equal to 0 because I'm only dealing with the topmost situation. And that's okay because this distance for y is also at the topmost situation. Right now I'm just going to find V naught y, but then since I know the angle theta, I can come back and find V naught. So let's see, let's just simplify this a little. I have 10 equals V naught y times t plus 1/2, I think, minus 5 t squared, because ay is equal to -10. And then over here I have 0 equals V naught y minus 10 times t. So I'm going to let V naught y equal 10t. I'm going to say that V naught y is equal to 10t. No, it's positive 10, because I take this side and bring it over here, and I get V naught y equals positive 10. And then I take this, and I plug it in for V naught y. So I get 10 equals 10t squared minus 5t squared. 10 equals 5t squared. T is the square root of 10 over 5, or 2, which is, what's that, 1.4, I think? No, right, or is it 1.3? I think it's 1.4. Yeah, 1.4. All right, so that is my time. And so if I want to know V naught y, I plug that in there. I say V naught y equals 10 times 1.4, which is 14. That's my V naught y, 14 meters per second. So I take this, I put it over here. I say 14 equals V naught sine of 30, I think it was. And so V naught equals 14 over sine 30. I would never ask you to do that on the test, but on the quizzes, y'all should know how to solve a system of two equations. It is important for you, just as a life skill. Yeah. Tell me your name again. William, perfect. William, what's... How did you do it? Right here. Oh no, but you don't know that V naught y is 0. It's not 0 in fact. Yeah, I'm not sure how that worked out, but it should work out because V naught y is not 0. Okay. The velocity at the top is 0, but not the velocity here, especially if you put in 10 here. Well, it's just the y component, not just, it is the y component. So before we were just dealing in one dimension, so we didn't differentiate between x and y. But now that we're dealing in two dimensions, we have to differentiate between what we're doing in the y direction and the x direction. No, it's not. No, V naught y is not 0. Now you could, maybe this is, then I haven't read yet. Is it about this? Or what is it? Right here, I put in 10t, so I have 10t times 2, which is 10t squared. William, I need to think about what you're saying. I'm not sure that I understand exactly. Yeah, I think I see what you're saying, and I think you're right. I need to think about it. Can we think about it? Okay. Maybe we can talk. Figure out. I don't want to spend too much time on it. You're not going to see a problem with this involved on the test, but have we already had project? No, we haven't had projection test. Yeah. Yeah. Tanner. Yeah. That's what I think he's getting at, right? Yeah. Yes, you can do that. That's what you did. Yeah, let me show you what they're saying. That's pretty clever, actually. So instead of taking it like this, they're saying, why don't we just start right here, right? That's what y'all are saying. And then here, I can say that V naught y is equal to 0, and I know that it needs to drop 10 meters. Yeah, this is much better. So I say y is equal to V naught y times t plus 1/2 AYT squared, right? Am I right? That's what you did? And so this goes to 0, because now I'm saying that this is my beginning point, and V naught y is 0. And so y is negative 10 equals half of a, which is negative 5, times t squared. And so t is the square root of 2. That's clever. All right? That's 1.4 seconds. So that means that from here down to here took 1.4 seconds, or for it to go that half of the trajectory. So the total time in the air was 2.8 seconds. Right? T total is 2.8 seconds. Oh gosh, what was it asking for? I forget now. Okay, yeah, so we want to know V naught Y. Gosh, how would we get back? Or V naught, rather. Well, now that we know the time, we could go back here and plug that in, right? And we'll get the same velocity. Yeah, that's good. I like that.
Where would you put it?
You would, well, you know Y, and now you know T here and here. You would find V naught Y, and then you use this. Let me just do it, okay? I'm sorry, I don't want to get too bogged down in this, but so then we say now our T total is 2.8 seconds. So I say Y equals V naught Y times T plus 1/2 AYT squared. Y is going to equal 0. V naught Y, I want to find, this will be 2.8 seconds plus 1/2 of -10 times 2.8 seconds squared. And then I solve that for V naught Y. What do I get for it? I get 14 meters per second. Notice they're shifting around, though, where they're beginning in the problem. And you can certainly do that, right? That's nothing wrong with that. You just have to be careful with your... Okay. Clever, I like that. All right. All right, can we do some other practice problems? Yeah, all right. Often there is more than one way to work these. Let's try this number 3. I'll blow it up in case you don't have your workbook today. Spring-loaded gun shoots a ball in the horizontal direction from a height of 20 meters. It travels 3 meters. What is its initial velocity? This is on page, I don't know. What page is that? One what? Oh. Oh, it's in the back. It's exam 2. Number 3, right. Find your time, and then you can find your initial velocity. Notice it is horizontal here, horizontal motion. Feel free to share your answer. Many of you are sort of honing in on the same answer. about 15 more seconds. Stop at, say, 255. 255. I'll go on to 3. Just guess if you don't know. Stopping at 3. Okay, good. B is right. So I first use the height to find the distance to find the time. Let's say y equals v naught y times t plus 1/2 ay t squared. V naught y is 0 because it's horizontal. So I'm going to get rid of this completely. Y is negative 20 because I start at 0 and I go down to negative 20 meters. That's equal to negative 5. That's half of negative 10 times t squared. So t is the square root of 4 or 2 seconds. And then it goes a distance of 3 meters. I say x is equal to vx times t. I know this distance is x equal 3 meters. So I say 3 equals vx times t, which is 2 seconds. So vx equals 1.5. So B is the right answer there. All right, let's try another. We have a couple minutes. Let's try this number 5. We'll get a number 5 here. Which of these vectors shows the velocity at point y, at this point? So horizontally out. Which vector shows the velocity vector at point y? We'll do number 6 after this, so if you're done with 5, go ahead and do number 6. And I'll stop this at 1 minute. 5 more seconds. Okay, good. B is right. Remember, it has both x and y components. It has an x component in that direction and a y component in that direction. So the resultant vector is B. And then let's do C6, number 6. All right, I'll stop at 40. 40. Stopping at 40. What now? Well, you can pick the answer from it. Let's see what everybody put. The answer is D. It's equal to the acceleration due to gravity. There is no other acceleration. Have a good day.